This is a video about how to solve Coulombs law problems. So here's a question that says we've got P1 and P2, which are both protons, and electrons on top there. The distance D1 is 6.2 times 10 to the minus 15th meters. Okay, the distance D2 is 3.1 times 10 to the minus 15th meters. And we want to know what the magnitude of the force is that P2 experiences from P1. So right here we want to know what P2 experiences from P1. So first let's figure out the magnitude. Okay, so there's our equation. That's Coulombs law. K is that constant right there. P2, the proton, has a charge of 1.6 times 10 to the minus 19th. The other is a proton, so it as well has a charge of 1.6 times 10 to the minus 19th coulombs. Remember, we're going to leave the negatives and positive signs out right now because they're not really helping us out as far as direction goes. The distance between them, like we said, is 3.1 times 10 to the minus 15th meters, and we got to remember to square that. So we get a value of 23.98 newtons, and notice that because that's a positive charge and that's a positive charge, P2 is going to experience a force to the right of 23.98 newtons. So that's the direction that it goes to. Now, let's find the magnitude of the force that P2 experiences from the electron. So there's an electron up there, and there's P2. So again, we use Coulombs law. Okay, K is this constant again. The charge of the proton is still 1.6 times 10 to the minus 19th. The charge of the electron is the same value, but negative. Again, we leave the negatives and positive signs out because they're really not helping us out with the directions right now. The distance between them is 6.2 times 10 to the minus 15th meters. And again, we got to remember to square that. And because this is positive and this is negative, they're going to attract. And so the positive charge is going to move upward with the value of 5.99 newtons. Okay, so now let's find the magnitude of the net force that P2 experiences. So this is from both of them. Now, right now, the way we've got these two vectors set up is they're set up tail to tail, and we can't have that. So we move this vector over and put the vectors together so that they are head to tail. And then we finish the right triangle. We're looking for that hypotenuse. We want to find that net force. So in order to find that, we've got to use the Pythagorean theorem. So the net force is going to equal that value of 24.7 newtons. So that's just the magnitude. Okay, so what we will also need is the angle. So we need that angle right there. So let's use the inverse tangent of the opposite side. That's the opposite side divided by the adjacent side. And therefore, that angle, 14 degrees, is right there. Okay. All right. Now, we want the magnitude of the net acceleration that P2 experiences. So Newton's second law says the sum of the forces equals the mass times acceleration. In this case, we only have one net force, and that's that value there, the 24.7 newtons. So we take that value and we plug it in there for our force. The mass of this object is the mass of this proton. That's a proton that we're accelerating. That's a proton that we're interested in. It's the one that's experiencing this net force. So if we look on our table of information, remember table of information is really important. It tells us that the mass of the proton is 1.67 times 10 to the minus 27 kilograms, and that gives us a value of 1.48 times 10 to the 28th meters per second squared. So that's our acceleration. Okay, and the way we plug that into our computer when we're entering in our answers is in this format, 1.48 E28. You don't have to put that in a subscript, just put E28, and that's how we get that answer. So notice that this acceleration is in the same direction as that force. Newton's second law says the net force and the net acceleration have to be in the same direction. With that being said, this angle Now, the angle of the net acceleration that it's asking us for, that P2 is going to experience, since this is the same direction as the net force, they have to have, therefore, the same angle. All right. Now, let's look at what the, let's answer this question. It says, if P2 starts from rest and that acceleration is constant, which it probably won't be, how fast will it be moving out after 1.3 times 10 to the minus 22 seconds? So we go to our kinematic strategy. We don't know how far it's going to go. That's not given to us. We know the initial velocity is 0 because it's telling us it's starting from rest. We're looking for the final velocity. That's what it's asking for. The acceleration we calculated from earlier, and it's telling us the amount of time. So with that being said, we know these are the 4 variables. 3 that we know, 1, 2, 3, and the 1 that we're looking for. The only equation that has all 4 of those variables in our kinematic strategy is that equation there. So we plug our values in. The initial velocity is 0. The acceleration is that value, 1.48 times 10 to the 28th. The time is 1.3 times 10 minus 22 seconds. And we get a velocity of, that looks like 1,920,000 meters per second.